So, having familiarized ourselves with the symbolization for quantifier logic, we're now finally in a position where we can construct our first proof. We've also familiarized ourselves with the 5 new rules that are going to go along with our 20 rules. So here's our first proof. In English, the argument is as follows. All Zionists are Jewish. That's the first premise. No Muslims are Jewish. That's the second premise. However, there are Muslims who are Israelis. That's the third premise. Therefore, some Israelis are not Zionists. That's the conclusion. This argument, I think, if you look at it, can you tell that it's valid just by thinking about it? Probably not. But we don't have to rely on that. We can construct a proof of its validity. So with an argument like this, the first thing we want to do is de-quantify or remove the quantifiers from our 3 premises. Now, we're going to use a strategic combination of UI and EI. The first thing I want to do is draw your attention to the second line. Notice there that we have not an existentially quantified sentence, but the negation of an existentially quantified sentence. As it stands, this particular sentence is not eligible to be de-quantified. In general, unless a quantifier ranges over the entire sentence, or another way of looking at it, there is nothing before or to the left of the quantifier, then it's not valid to employ the general EI or UI. So there's a tilde before the existential quantifier in line 2. So line 2, not eligible to be de-quantified. Here's one of the most common uses of the QN rule. The QN rule will allow us to convert line 2 from a sentence that can't be de-quantified as it stands into one that can. So the first step in this proof is to QN. So you might want to refer back to the notes I've given you in the previous video about how to employ QN and the other rules. I was thinking about that. Some people have asked me if I could possibly type out all of the information regarding the rules and provide it for you. And I think it's more helpful for me to write it out, and this is the important part, for you to write out how the rules work yourself and get the additional learning involved there, instead of just having stuff pre-written out before you. It's just a way of adding some extra concentration. So that being said, we want to apply the switch, switch, switch procedure. Tilde before the existential quantifier, remove it. The existential becomes a universal quantifier. And then between the conjunction and the quantifier, there is no tilde, so we put one there. Everything in the brackets stays exactly the same as it was. Now we have a situation, having done the QN on line 2, where line 4, nothing before the universal quantifier, it's eligible to be de-quantified. So we've got line 1, line 3, and line 4. So suppose we start off with line 1, UI. So what should we put when we replace the 2 occurrences of the x-bound variable and remove the universal quantifier? Well, we could put the name of some individual, or we could put a free variable. Notice line 3, that's an existentially quantified sentence. Existentially quantified sentences, when you remove the quantifier, there's restrictions on EI. So, for the EI, it's going to have to be a free variable, and not only that, it's going to have to be a free variable that's new to the proof. So, you don't want to do the UI first, because if you do, there's going to be no way you can comply with the restrictions on EI and line up the subjects of the 3 sentences as one and the same. So in other words, whenever there's an EI to be done, the EI always gets done first. So after the QN, then we do 3 EI, and we remove the existential quantifier and the bound x variable that goes with it, as well as the brackets around the conjunction, indicating that the quantifier ranges over them. And in the 2x slots, we put a free variable that hasn't occurred earlier. Since there are no free variables in the proof yet, we'll just put v. Having done the EI, we now do 1 UI and 4 UI. And what we want to do is make sure that all 3 sentences pertained to the same subject, namely unspecified v. So 1 UI is going to give us, if unspecified v is a Zionist, then unspecified v is Jewish. 4 UI is going to give us, it's not the case that unspecified v is Muslim and unspecified v is Jewish. So that's 4 UI. So in steps 5, 6, and 7, we have de-quantified our 3 quantified sentences. At this point, look at the sentence we want as the conclusion. It's an existentially quantified conjunction. So, how are we going to get that conclusion? Answer, we're going to get the conclusion by e.g. So, given that our information is all de-quantified with unspecified v as the subject, what does the second line, or sorry, the second last line of the proof have to look like so that we can get the conclusion by e.g.? The second last line of the proof, and it might be useful to just write it down here, it's going to be unspecified v is Israeli, and it's not the case that unspecified v is a Zionist. Once we get that, then we'll just do e.g. to get, there's at least one x such that x is Israeli and x is not a Zionist. So we know that the last step of the proof is going to come via e.g. Hard to say how the second last step of the proof is going to come. It might come by conjunction, in which case we'll have to get these 2 separately. We might be able to infer it directly from some other combination of sentences. In any case, here's our task now, and I hope you'll agree this is very doable at this point of the course. Use the rules of sentential logic to derive this sentence from sentences 5, 6, and 7. So, couple of quick simplification steps. Then we'll do a De Morgan's on 7 to get tilde MV or tilde JV. Then, so that's 7 De Morgan's. Now we will do eight double negation, setting up for the disjunctive syllogism. Notice the way things are going to end is taking up necessary room. If the board were a little bigger, it would have been to our advantage to put them down a little further. So now we'll just have to remember this. So we're looking for a sentence of the form IV and tilde ZV. So 1011 disjunctive syllogism. That'll give us tilde JV. Then 612 modus tollens will give us tilde ZV, so that we will be doing a conjunction step. 913 conjunction will give us and finally, as planned, we now do the EG on that conjunction. So that's 14 EG. So there's our first proof in quantificational logic. Some things are pretty familiar. Line 8 to line 14, just a series of sentential logic steps. Almost all of them were basic rule employments, but there was a double negation and disjunctive syllogism. At the beginning, we saw 3 dequantification steps, 1 EI and 2 UIs. We saw a QN adjustment because line 2 as it stands isn't eligible to be dequantified. And we ended the proof with a requantification move, the unrestricted EG. So there's our first proof in quantificational logic. If these 3 sentences are true, it's impossible for this sentence to be false. Thus, the inference or argument from these 3 sentences to this conclusion is a valid one. So, what did you think of the first segment in our video? I'm experimenting with the camera, so I thought I'd try the vivid setting. I think that's what Donald Trump's secret is. You put things on the vivid setting and your skin turns orange. I'm trying this video on a different setting, so we'll see how this one turns out. We move on to our second argument, which is about the same level of complexity. In English, this argument says, all screen stars are attractive. Some screen stars are feminists. All attractive persons are envied persons. Therefore, our conclusion, some feminists are envied persons. With this argument, our premises are 2 universally quantified sentences, 1 existentially quantified sentence, and we want an existentially quantified sentence for the conclusion. In this case, there are no tildes before any of the quantifier bound variable pairs, so no QN steps are necessary. So all we have to do is proceed with the dequantification process. Question: which dequantification do we do first? Should we go 1 UI, 2 EI, 3 UI? You wouldn't want to do this on the test because you will be penalized. Why would you be penalized? Because if you do the UI first, even if you pick a free variable, in order for the EI to be done correctly, it has to be a free variable that's new to the proof. So it can't be the same free variable as the one done, as the one used when you did the UI on line 1. On the other hand, though, it's essential that you have the same subject in all of your premises. So, the easy solution, do the EI first. So, there's at least one X such that X is a screen star and a feminist. 2 EI. Unspecified V is a screen star and unspecified V is a feminist. Now that we've got the dequantification involving the rule with restrictions out of the way, we can do in any order 1 UI, 3 UI. And when we do these 2 UIs, what we want to do, of course, is put unspecified V in the bound variable slots where we're moving so that all of our information is in terms of the same subject, unspecified V. If unspecified V is a screen star, then unspecified V is attractive. 3 UI, if unspecified V is attractive, then unspecified V is envied. Now, we just have to carry out a sequence of strategic sentential logic steps in order to end up with a sentence that will enable us to, with the final use of an EG, get our conclusion. So again, in the early stages, many people find it easier to have the way the proof's going to end clearly set out for them. So, what we want to end up with is the sentence, there's at least one X such that X is a feminist and X is an envied person. Given that our information is in terms of unspecified V, the second last line of the proof is going to say unspecified V is a feminist and unspecified V is an envied person. So, all that remains is to use the rules of apply the rules of sentential logic to lines 4, 5, and 6 to get line 11. Then we do the EG to complete the proof. Once again, the sentential logic part, pretty simple. We start off once again with a couple of simplification steps. Now, we could do 2 modus ponenses, or we could do a hypothetical syllogism and a modus ponens. Suppose we go for the hypothetical syllogism. 5, 6. Is going to give us if unspecified V is a screen star, then unspecified V is envied. 7, 9 modus ponens. unspecified V is envied, 810 conjunction, now that we've got the sentential structure we want, 11 e.g. and we're done. So I hope you're already starting to get used to this new format here. What we do at the beginning is just dequantify all the sentences, making a QN adjustment if necessary, which it wasn't in this case. A series of sentential logic steps, and we ended off with the e.g. Alright, so that second video looked a little more normal, so I think we'll stay away from the vivid mode. Here's a third argument for us to consider, and this argument comes from Lewis Carroll's book on symbolic logic, which was produced in the late 1800s. And yes, this is the same Lewis Carroll who wrote Alice in Wonderland and Through the Looking Glass. By day, he was a logic mathematics professor, although, as you're going to see when we consider the details of this proof, he used his imagination in his logic class. So, the argument goes as follows. All babies are illogical. No one is despised who can manage a crocodile. Illogical persons are despised. Therefore, no baby can manage a crocodile. You might want to pause the video and see if you can construct this proof on your own. Perhaps the way I'm going to construct it will be a little different from the way that you'll construct it. We'll see. We're going to begin to consider alternative ways to construct proofs. Not surprisingly, there's going to be a very limited number of alternative, entirely correct ways to construct proofs in quantificational logic, but of course there's always going to be an endless range of different ways to screw it up. Alright, so I look at our initial premise set, and I notice that, like the first argument, we've got a negated sentence. So the first step I do is to QN, which gives us all x are such that it's not the case that x is despised and x can manage crocodile. So now I've got a situation where premises 1, 3, and 4 are all universally quantified, as is the conclusion. So this is going to be a case where, in order to get that conclusion, we're going to have to do a UG. So the requantification rule is going to be the one that has restrictions. The last two arguments we did an EG, so we didn't have to worry about restrictions. And not because it's going to save us any steps, it might even add some additional steps, but we'll do it via the CP subproof. So as soon as you decide to do an argument like this via the CP subproof, I'll just chart out how it's going to predetermine the overall structure of the proof. So, since the 3 lines of information we have are all universally quantified sentences, we can dequantify them via UI, no restrictions, so we don't have to worry about introducing a free variable via a provisional assumption. So the idea is we're going to want to end up with this conditional via CP, and once we have that conditional via CP, the last step of the proof is going to be the UG. So notice then, this is one of these cases where there's going to be a temporary restriction on doing UGs while we're still in the subproof, but we're not going to do the UG until after we've exited the subproof. So, having made the provisional assumption, we've determined that the subject of the sentences is going to be unspecified V. So, we just now go 1 UI, 3 UI, 4 UI to get BV horseshoe tilde LV tilde LV horseshoe DV and tilde DV and MV. Before I proceed on, one thing to point out, notice there's nothing restricting the provisional assumptions we make. In other words, we could have made a provisional assumption where Frederica's name goes in the slot. Nothing preventing us from putting names in the slot when we dequantify universally quantified sentences. So all four of these could have involved the name of a specific individual. Nothing preventing that. So why did I do everything in terms of unspecified V? Answer, because the UG at the end requires that all of the information be processed in terms of a free variable. That is to say, in terms of an unspecified subject. In other words, if we want to demonstrate that a particular property holds of every entity, namely, if they're a baby, then they can't manage a crocodile, we need to demonstrate this not of a specifically named subject, but of every subject in general. So, another way of putting this, what we're going to do is do this by a free variable. Second, a free variable that didn't come from an EI. So in other words, there's nothing special about V. We could have run this whole process using unspecified W or any number of different unspecified free variables. So what we're doing here is using what's sometimes called the principle of induction. Having demonstrated that this relation holds for a randomly selected individual, we have thereby demonstrated that it holds for every individual. Okay. Now though, all we have to do is construct a sequence of sentential logic steps that takes us from these four sentences to this sentence. Then we've planned this out. We're going to exit the proof by CP. Once we do that, we're going to do the UG, and we're going to be eligible to do the UG at that point. All right, let's just hope I don't run out of room. May as well start off with 8 De Morgans. Five, 6 modus ponens will give us tilde LV. 7, 10 modus ponens. Of course, you could have done a hypothetical syllogism instead, will give us dv. Then could have done double negation on 11 and disjunctive syllogism, or it ends up being the same thing. We can do implication and then modus ponens. So 9 implication, a little bit of an unsightly gap. Better to have too much room than not enough though, because then you have to start erasing things. 11, 12, modus ponens. So 5 to 13, CP, and notice at line 14, the temporary restriction on doing UGs on unspecified V is now lifted. All of the other occurrences of V came into the proof via UI. There are no EIs. So we have satisfied the restrictions, and we can correctly infer by UG that all X are such that if X is a baby, then X cannot manage a crocodile. So, if you look on the class homepage, you'll see that I've now uploaded assignments 12 and 13. These are assignments for constructing proofs in predicate logic. So we'll give you a couple of days with those, and then we'll move on to constructing proofs with relational logic. It's a little more complicated. There are no new rules, but it's good to get accustomed to doing these new kinds of proofs in the somewhat simpler fashion before we move on to the relational ones. So, in assignment 12, I apologize, the questions didn't come out quite as clearly as I might have liked. You can still make them out though. So, what we have in assignment 12 are two sets of 10 questions where you have English arguments. You have to symbolize the arguments and then construct proofs for them. Now, I want to emphasize that test 4 is only going to involve constructing proofs for symbolized arguments that you will be given. Assignment 13, which I'm also putting up on the home page, just has a collection of 20 symbolized arguments. So we'll start off with argument 1 in the section on the left. In English it says, if all the physicians are either hematologists or neurologists, then there are no cardiologists. But Dr. Frank is a cardiologist, therefore some physicians are not neurologists. I suppose this would have been at some sort of convention where they're talking about the different kinds of physicians that are there. Notice how this sentence has to be symbolized. The first premise is a conditional. It's a conditional of a universally quantified sentence and a negated existentially quantified sentence. If all of the physicians are either hematologists or neurologists, if that's so, then there are no cardiologists. The second premise, very simple, Dr. Frank is a cardiologist, so this gives us our conclusion, some physicians are not neurologists. In other words, there's at least one X that's a physician and not a neurologist. So, how do we start this one? This is an example of a different kind of proof construction situation. So there's a broad range of proofs, like the ones I've already shown you, where you start off dequantifying all of the premises, then you do some sentential logic, and then you do requantifying at the end. This is an example, though, of a proof that isn't like that because, and I'll emphasize it again, the four quantifier rules apply to entire lines only. So in other words, what we've got here is a situation in premise 1 where the universal quantifier only ranges over the stuff in the square brackets. The existential quantifier only ranges over that very short sentence. So you're not allowed to snap off the quantifiers in either the antecedent or the consequent. So how are we supposed to construct this proof then? Answer, well, we have to go back to the principles of sentential logic. So the first premise is a conditional. You can't validly derive anything from a conditional all by itself. You have to have either the antecedent of the conditional, then by modus ponens you can derive the consequent, or you have to have the negation of the consequent, then by modus tollens you can derive the negation of the antecedent. So, does there seem to be much chance of being able to derive the antecedent of line 1 from the information we have? No. Does there seem to be much chance of deriving the negation of the consequent? Yes, there is. All we have to do is think about it logically. So what is the negation of the consequent of the conditional in 1? Well, it's tilde tilde, there's at least one x such that x is a cardiologist. By double negation, it's just there's at least one x such that x is a cardiologist. Do you see how we could get that from the information we have in 2? Okay, so here's how we proceed. If Frank is a cardiologist, so notice I've got the name of a specified individual in that slot, then 2EG gives us there's at least one x such that x is a cardiologist. Now to get the consequent of the conditional with a tilde in front of it, I doubly negate the entire sentence 3, so that's 3 double negation. Keep in mind, no additional brackets are necessary. The outermost tilde refers to the first full sentence immediately after it, which is the whole thing. The innermost tilde refers to the first full sentence immediately after it, which is the remainder. And the existential quantifier operates just like a tilde. It applies to this. Okay, so we did an EG and then a double negation. Now we're entitled to finally get at the information in line 1, 1 for modus tollens. So what does that give us? Well, it gives us the antecedent of the conditional with a tilde in front of it. Okay, so now that we've got that, can we dequantify that? No, we can't dequantify that either. But, unlike the first situation, all we have to do is make an adjustment to this sentence using the QN rule, then we will be eligible to dequantify it. So, 5 QN will give us there's at least one x tilde, and then everything in the square bracket stays the same. All right, so we can do an EI on line 6. Recall though the EI requirements say it's got to be a new free variable. I don't see any free variables in the proof. There's a name, which we couldn't have used when we did the EI anyway, so we'll use unspecified V. It's not the case that if unspecified V is a physician, then unspecified V is a hematologist, or unspecified V is a neurologist. So that's going to be 6 EI. Look at our conclusion. We want to end up with there's at least one X such that X is a physician and not a neurologist. So we might want to plan that out beforehand. So we want to end up with there's at least one X such that X is a physician and it's not the case that X is a neurologist, given that our subject matter is in terms of unspecified V. We'll just want to end up with the sentence unspecified V is a physician and it's not the case that unspecified V is a neurologist. So in line 7 we've got a negated conditional. I hope you remember the two-step process for dealing with negated conditionals. First we do an implication on the stuff inside the brackets to make that conditional a disjunction. Then we do De Morgan's. So this is going to be tilde PV or HV or NV. So that's 7 implication. See, there's no getting away from the sentential logic. You need to have mastered the sentential logic throughout the course. 8 De Morgan's will give us tilde tilde PV and tilde HV or NV. Now we're going to have a number of fairly simple little steps. First, tilde tilde PV and then PV, so that's 9 simp ten double negation. So we're going to get PV and tilde NV by conjunction and then do an EG. So all we have to do is get tilde NV. I'm going to have to erase this. I should be able to fit it in the space if I write a little smaller. Tilde HV or NV is just 9 simp again, 12 De Morgan's will give us tilde HV and tilde NV. 13 simp will give us tilde NV. And remember, we wanted PV and tilde NV, so that's 11, 14. Conj. And we end off the proof as planned. 15 EG. So if unspecified V is a physician and not a neurologist, then there's at least one X such that X is a physician, and it's not the case that X is a neurologist. So, a fair amount of sentential logic. We've also got some of the new stuff. We've got an EI and a QN, we've got an EG. And the best way of getting familiar with this stuff, like anything else in this course, by doing as many proof construction questions as you can. This might strike you as harder and more complicated than it really is, just because some of the stuff in here is new. The way to make it easier, more understandable, is by doing a significant number of proof construction questions. So there's going to be 20 proof construction questions in assignment 12, another 20 proof construction questions in assignment 13. So that's plenty of proof construction questions to enable you to familiarize yourself with this new proof construction process. It's somewhat like the proof construction process in sentential logic, but it's also somewhat different. At this point, we'll move on to consider question 4. We're still on the left-hand side of assignment 12. So in English, it says, either some general practitioners are pediatricians, or some surgeons are endocrinologists. But it's not the case that there are any endocrinologists. Therefore, there are some pediatricians. This argument we can symbolize as follows. There's at least one X such that X is a general practitioner and a pediatrician, or there's at least one X such that X is a surgeon and endocrinologist. But it's not the case that there are any endocrinologists. Therefore, there's at least one pediatrician. Once again, we're in this situation where we could, if we wanted to, do a QN on line 2 and then dequantify it, but line 1 can't be dequantified as it stands, nor can we transform the information in line 1 in such a way that it would be eligible for us to do some dequantification. So it's a disjunction. We need to have the negation of one of the disjuncts to move on. So that's what we need to figure out. How could we get the negation of one of those disjuncts? Well, what other information do we have? Well, the second line is close to the negation of the right disjunct. The right disjunct says there's at least one X such that X is a surgeon and endocrinologist. Line 2 says it's not the case. There exists an X such that X is an endocrinologist. So, in order to proceed, we're going to have to transform the information in line 2 so that it's the negation of the right conjunct. How are we going to do that? Well, first thing we're going to have to do is dequantify it, and in order to dequantify it, we're going to have to do a QN. So that's going to give us all X are such that it's not the case that X is an endocrinologist. So, now we can do a UI on line 3. So we could put a name in there, we could put Dr. Frank from the previous proof's name in there, or we could put a free variable. We're going to put a free variable because ultimately we're going to want to do some re-quantifying in order to end up with the negation of the right disjunct. So, how are we going to get the negation of the right disjunct? Well, we're not going to get it by doing an EG, because that would have the tilde behind the quantifier. You can't use the two rules for taking quantifiers off, EI and UI, on parts of lines, nor can you use the two rules for putting quantifiers on, EG and UG, on parts of lines. So here's what we're going to have to do. So 3 UI tilde EV. It's not the case that unspecified V is an endocrinologist. So we want to end up with the negation of this. Maybe I'll just jot this down over here. It's not the case that there exists an X such that SS, SX, and EX. So how are we going to get this sentence? We're not going to get it by EG. Well, we can get it by QN. What sentence would we need to have to get this one by QN? We would need this sentence. If we could just get this sentence, then we could get this one by QN. How are we going to get this sentence? Well, we'll get this sentence by UG. That's a restricted rule for putting quantifiers on. So we're going to have to make sure we don't violate any of the restrictions. What sentence would we need to have, though, if we were able to figure out a way to correctly get this sentence by UG? Well, we'd have to have the sentence it's not the case that unspecified V is a surgeon and an endocrinologist. If we could just get that, then we get this guy by UG, then we get this guy by QN, so we can do the disjunctive syllogism. How are we going to get this guy? Well, hopefully this is not a big surprise. We'll get this guy by De Morgan's. If we could just get this sentence. How are we going to get this sentence, given that we've got this? Hopefully a light comes on at this point. So, we've got, it's not the case that unspecified V is an endocrinologist. So we do a disjunction, an addition step to get this disjunction. Then we do a De Morgan's, then we do a UG. We'll hold it here. Where did unspecified V come into the proof? By UI. Another instance of unspecified V is going to come into the proof by the addition step we do, but there's nothing restricted about that. And again, the reason there's nothing restricted is there's nothing special about us using unspecified V here. We could have done the same routine using unspecified W or any number of different sentences. Okay, so now we've got a plan. Notice how much easier the backwards planning made our plan. That might have been a little difficult to figure out from the top down until you get used to this stuff. But now we've got our plan. So, availing ourselves of the two-sided addition rule, we're going to go from, it's not the case that EV to tilde SV or tilde EV, so that's for addition. Then, as planned, five De Morgan's, and since the V came from the UI, no problem. Doing 6 UG, and finally, seven QN. So that sequence of steps got us to the point we needed to be. 1-8 disjunctive syllogism. Will give us the left disjunct. So now we've got, there's at least one X such that X is a general practitioner and a pediatrician. We want to end up with the sentence, there's at least one X such that X is a pediatrician. Well, we'll have to dequantify and requantify. To dequantify line 9, we're going to have to do an EI, so that's 9 EI. Remember the restrictions. To do an EI, it has to be a free variable that hasn't occurred earlier in the proof. So notice V has occurred earlier in the proof. We don't want to be smuggling in information we're not entitled to. So we will do the EI in terms of unspecified W. Once we have unspecified W is a general practitioner and a pediatrician, we just snap off the conjunct we want. And then there's at least one X such that X is a pediatrician. It's just 11 EG. Well, hold it. Can we do that EG? Because we're doing it on unspecified W. Not a problem because EG is unrestricted. We couldn't have, and we shouldn't have been able to, do a UG on that, so we're certainly not entitled to conclude from these two premises that everyone or everything is a pediatrician, but we are entitled to conclude because these two premises entail the truth of there's at least one X such that X is a pediatrician. Okay, so there is some interesting sort of thinking that was required here, and the only way to explain to you how to do it is to say, well, you need to think logically, you need to be systematic and think about the tasks that you need to complete, but more deeply, you have to be familiar with and comfortable with what this symbolic stuff means, and the only way to get to that place is by doing lots of proof construction questions. We're now going to move on to a question from assignment 13. This is question 15. The argument itself isn't particularly interesting, but it's got a feature of the proof we can use to construct it that we haven't seen before, and I think it's going to be useful for you to be aware of. So these arguments all come symbolized, although again I think it's useful, if you can, to think through an interpretation of what the symbolic stuff means. So for this example, the argument might be, all x are such that if x was born in Hungary, then x has been to Krakow. Suppose that's true. The second premise, there's at least one x such that x was born in Hungary, or there's at least one x such that x has been to Krakow. From that we can conclude there's at least one x such that x has been to Krakow. What are we going to do with this situation? The second premise, a disjunction, so we can't dequantify either of the disjuncts. The first sentence, we can dequantify it because we've got a universal ranging over a conditional, but once we dequantify it, how are we going to use that information in order to get information out of the second premise? Having a non-quantified conditional isn't going to get us too far as availing ourselves of this information. So, in a case like this, now that we know the subproofs, the strategy of despair, the strategy when you can't think of anything else to do, is no longer distribution, it's now going to be indirect proof. In other words, if you just can't think of a way to construct a direct proof from the premises to the conclusion, you can construct that proof indirectly by provisionally assuming that the conclusion you're after is false, and then deriving a standard contradiction. So, we make the provisional assumption that the conclusion we're after is false, namely that it's not the case there exists an x such that x has been to Krakow, given that these two premises are true. Now that we've got this additional information, two, three, disjunctive syllogism. So notice we're treating these existentially quantified simple sentences just as parts of what's going to be a sentential logic construction. So we've got a disjunction, we've got the negation of one of the disjuncts. By disjunctive syllogism, we get the other disjunct. Okay, so now we've got an existentially quantified sentence and a universally quantified sentence. Remember, at this point, because we've decided to go the IP route, we're looking for a standard contradiction. We're not exactly sure yet what that standard contradiction is going to look like. Well, how about if we dequantify the information in lines 1 and 4, making sure to do the EI first because we want the subject to match. So we'll do the one with restrictions first, follow that by the UI. So if there's at least one x such that x was born in Hungary, then unspecified v was born in Hungary. If all x are such that if x was born in Hungary, then x has been to Krakow, then if unspecified v was born in Hungary, then unspecified v has been to Krakow. So now 5, 6 modus ponens will give us unspecified v has been to Krakow. All right. We're looking for a standard contradiction. How are we going to get that standard contradiction? Well, here's an idea. If unspecified V has been to Krakow, then by e.g. unrestricted, there's at least one x, namely unspecified V, such that x has been to Krakow. But look at our original provisional assumption. It's not the case that there exists an x such that x has been to Krakow. So 3, 8 conjunction will give us there's at least one x such that x has been to Krakow, and it's not the case there's at least one x such that x has been to Krakow. Oh, little error there. I'm sure you noticed it watching the video. When we do the e.g., we're going to remove the free variable and put the x bound variable. So now when we go 3, 8 conjunction, we end up with there's at least one x such that x has been to Krakow, and it's not the case that there's at least one x such that x has been to Krakow. So any standard contradiction will do, including one which is a standard contradiction of an existentially quantified sentence, and that exact same sentence with a tilde in front of it. And recall from sentential logic the fact that one of the conjuncts in the conjunction that is a standard contradiction was the provisional assumption. There's no restriction against that either. So, since the provisional assumption that it's not the case that there exists an x such that x has been to Krakow led to this standard contradiction, 3 to 9 by IP, we're entitled in inferring there's at least one x such that x has been to Krakow, what we were aiming for all along, which follows from the original premises alone. So that will end the demonstration of proof construction for predicate logic proofs. So you've got assignments 12 and 13 on the home page, and both of these assignments have the questions on the first page of the file, and the solutions are right there. So try to do as many of those questions as you can, and in a day or two I'm going to move on to provide some illustrations of proof construction in relational quantificational logic.